Welcome to Unit 6A video lesson number 1. The reading to go along with this video is broken up into 3 chapters and can be done either before or after watching this video, depending on which one you think is going to be more helpful to help you understand these topics. The topics you'll be reading about are relations defined parametrically, parametric equations, parametric curves, eliminating the parameter, and the equation of a sphere. I promise this does fit in with the rest of them, you'll see later. But for now, let's figure out what all these parametric stuff is about. Parametric curves and parametric equations. Official definition. The graph of the ordered pairs x and y, where x equals f at t and y equals g at t are functions defined on the interval I of t values, is a parametric curve. The equations are parametric equations for the curve. The variable t is a parameter, and I is the parameter interval. So let's break that down a little easier to understand. The basic idea of parametrics is that parametric equations define x and y separately instead of putting them all in the same equation. And the variable that is defining x and y is t. That's called the parameter. So x and y are defined in terms of t. Calling something a parametric curve just means that's the graph of those two functions put together. Now let's talk about the parts that you'll be seeing. First of all, t. As I said, that's your variable. It's called the parameter. You're always going to have two equations, an x equation and a y equation. Those are called your parametric equations. And lastly, you've got this parameter interval. The interval I is just saying which t values you want to plug in. So let's say I only want to use the values of t between 0 and 5. Then that is your parameter interval. Those are the only values you're going to be plugging into your x and y parametric equations. So now let's talk about a graph. How do we graph these? Well, remember when you were having to graph pretty much anything else, you would make a table, x and y. We're still going to be doing that. The main difference is now we also have a t column. Now if we're going to be graphing for part A, we want to enter the t values between -3 and 1. Now, to make things easier, we're going to make the change of t or delta t equal to 1, which just means that I'm not going to be graphing officially all of the points between 3 and -2. I'm just going 3, -2, -1, 0, 1, and those are going to be my t value points. So let's make this table. To find my x and y values, please note we don't have a t-axis. We're not actually graphing any of these numbers. They're just used to find the xy coordinates. To find the x coordinates, you plug in t up here to the x equation. Let's make that red. The x equation. So, t squared minus 2. -3 squared is 9, minus 2 is 7. -2 squared is 4, minus 2 is 2, etc. When I plug in -1, I get -1. When I plug in 0, I get -2, and then -1 again. All of these, I just plug it into x equals t squared minus 2. To get my y values, I'm plugging it into my y equation. I'm just, once again, taking my t values and plugging them in, so each of them will be 3 times what the t value was. 3 times -3 is -9, 3 times -2 is -6, etc. And now these will be our xy coordinates, 7, -9, 2, -6, etc. And you can simply plot the points like you would normally plot any other points of any other two-dimensional graph. 7, -9, 2, -6, -1, -3. I hope you're graphing this on your notes as well as me. I'm not just doing this for my own benefit. And -1, 3. From here we can then connect those dots, and we'll see that we end up with something that looks very much like a piece of, what? A parabola. Now I want you to try B and C, and see how that changes what the graph looks like when you just change your interval of your parameter, t. So pause the video and graph those two. Really, pause it. I'll wait. Oh, are you back? Oh, good. Let's see if you did that right. Alright, so this is what B should look like. You're graphing your t values between -2 and 3. So these were your x, y coordinates. And you end up with a separate piece of the exact same parabola. And in C, since we're going from -3 to 3, we'll have even more of that parabola. Please note that for none of these am I extending beyond and putting those little arrows, because I have this interval and I'm only graphing within that interval. I'm not going beyond those t values, so there will not be those arrows. Now, let's talk about how you would have been able to do that in your graphing calculator. Page 128 in your book has an excellent description of using your graphing calculator for parametrics, but I thought I'd mention it here too. To get into parametric mode, go to Mode and click on PAR for Parametric. That'll give you an X and a Y in your Y equals area to enter your two equations. And then going to Window now has this option of T-min, T-max, T-step, and changing the min and max will change the interval of t. These are B and C that you were doing before. No, sorry, A and B that you were doing before. Now, eliminating the parameter. What does that mean? Eliminating the parameter is kind of algebraically figuring out what these things mean. It means changing into a normal xy equation. So instead of having the two parametrics in terms of t, t is eliminated, thus eliminating the parameter, since t is the parameter, and you end up with only one equation, x, y. There are two main ways that you can do this. And by the magic of movie making, there they are! Method number 1, solve, substitute, solve. It's the substitution method. You're going to be solving for t, substituting that t into the other equation, and then solving for y. Sometimes that isn't necessary, and sometimes you don't want to solve for y, but frequently you're going to want to solve for y so that you know what the graph looks like. Second method is to combine the two equations and simplify with the goal of eliminating t. We're going to show both of these methods for our first example, and in the second example you'll see that the second method is really the only one that works. So let's start with our substitution method. I start with my x equals t plus 1. To solve for t, all you have to do is subtract 1, algebra 1. This should look familiar. It's just being used in a different context from what you learned in algebra 1. Now I'm going to substitute my equation here for the t in y equals 2t. So I end up with y equals 2 times x minus 1. Now my third step was to solve for y. Y is already by itself, but I can still simplify. 2x minus 2, and that's the substitution method. How would you do this with the combination method, sometimes called combination and elimination? we're going to want to add these two equations together so that t cancels out. Right now, if we were to add these two equations together, we'd end up with 3t. That's not what we want. Let's make a little bridge, multiply everything in the x equation by -2. You'll see why in a sec. -2x equals -2t minus 2. Second equation doesn't need to be changed at all because you'll note, now when we add them together, the -2 and the 2t cancel out. We end up with -2x plus y equals -2, and you'll note that this is just the standard form of the exact same linear equation as y equals 2x minus 2. You could add 2x to both sides and make them both in slope-intercept form, but in any case, that is the combination method. In our second example, combination will be the only method that really works. You'll note that in this example we have sine and cosine, but don't get scared. To figure out how to start, we're going to graph it on our graphing calculator, and in parametric mode we have a circle. So let's talk about what we know about circles. That can tell us how we can start this. We know that the equation of a circle is x squared plus y squared equals r squared. You learned that in Algebra 2? This is the circle centered at 0, 0, since that's where our circle is centered. We also know from last semester that we have trig identities. And do you remember the most basic trig identity where you square two things and add them together? That's right. Sine squared plus cosine squared equals, do you remember? 1. We're going to use these two pieces of information and our combination type method that we used before in order to eliminate the parameter t. So we're going to add these two equations together, but not before we square each side. So we have x squared plus y squared on one side, squaring them and then adding them together, and we have 2 sine of t squared and 2 cosine of t squared on the other side. Simplifying, don't forget to square the 2, not just the sine. This is what we get. And since we have a 4 in both terms, that's a common factor. Factor it out. Hey, you recognize that sine squared plus cosine squared? We can replace it with 1. So we get the final equation of x squared plus y squared equals 4, which is a circle, radius 2, because 2 is the square root of 4. Now, after you finish watching this video, I want you to play around on your graphing calculator and figure out how you can change your t values, change your t intervals, to make it so instead of a full circle, maybe you only graph half of the circle, the top half, or the right half, or the left half, or maybe only a quarter of the circle. Changing the t values will change that. And making sure you're in radians versus degrees mode will make a difference, so make sure you know what mode you're in when you're changing your t values. Before that, though, let's talk about this whole, how can we apply this in 3D? We were talking about circles here. So what is a 3D representation of a circle? A sphere. And I was saying before I was starting with the easy one that was centered at 0, 0. This is the equation for a sphere centered at hk instead of 0, 0. So instead of just x squared and y squared, we have x minus h squared and y minus k squared. This is just your center. And r is the radius. So we're going to square the radius. How can we do that with a sphere? Well, instead of just x and y, when we're in 3D, we have x, y, and z. So instead of just h and k, we have h, k, and l as our center point. Once again, our center point is just being subtracted from x, y, z. And the radius is still on the other side being squared. Real simple example, and then I promise I'll let you go. What is the formula for a sphere of radius 8 centered at -2, 3, 10? Well, we start with our center. X minus, what's our x coordinate? -2. X minus -2. Plus, square that, y minus the y coordinate, 3, plus z minus 10, square that, equals the radius squared. From here, it's just, let's simplify. X minus -2 is the same as x plus 2. Don't have to simplify the y term. Don't have to simplify the z term. But we do know that 8 squared is 64, so we can do that. And we're done. This is the sort of thing that seems like, oh no, and then you learn how to do it and you're like, oh, well, that was easy. Like staples. Anyway, if you haven't already done the reading in the book, now's the time to do it. That'll help you get some other examples of how to do this, and we'll practice more tomorrow. See you in the morning. Bye.